So you ask, how am I going to get into space? Well, let me tell you. In 1961, Yuri Gagarin became the first man to reach space. Now, 57 years later, I'm planning on getting myself into space and then into orbit around planet Earth. To get into space, I'll be using the most recent Soyuz rocket so far. With 69 successful launches since 2004, it has proven to be reliable. Getting into space and then into orbit is an immense task due to the rocket weighing 312,000 kilograms. To overcome this, the four RD-107A rocket boosters provide a total of 3,357,925 newtons of thrust. That's equal to the weight of not one, not two, but 228 mid-sized cars. Now, Newton's third law states that every action has an equal and opposite reaction, which can be demonstrated with some foil and a match head. When the match head reaches its activation energy, the gases produced by the combustion are forced out the back of the mini-rocket, creating forward thrust. The same principle applies to the Soyuz 2 rocket boosters, but on a much larger scale. When the mixture of high-pressure oxygen and kerosene ignite, the gases are then forced out the back of the rocket booster, unbalancing the forces, meaning the upward force is more than the weight of the rocket. The rocket moves upward with masses of force, but interestingly, only up to about 4G. The rocket is now travelling upwards on its way to space. But how do you keep the rocket on its trajectory, I hear you ask? Well, let me explain. A gyroscope is used to keep the rocket from smashing straight down to Earth. A gyroscope is a spinning flywheel that will keep its position regardless of the enclosure around it. Electromagnetic sensors are placed around the enclosure to sense its position, and if the onboard computers sense that the rocket is off course, the outlet on the rocket's main engines move around to right the rocket's trajectory. To help the rocket keep steady, it is designed so it is aerodynamic. Now, let me explain aerodynamics. This is a small experiment to demonstrate the effects of drag. It's important that the rocket is aerodynamic enough to be able to pass through Earth's atmosphere with minimal air resistance. This will make the rocket more efficient at displacing the air around it. These two bits of paper are identical in size and mass, although the one that has been screwed up is more efficient at displacing air than the other, meaning it is more aerodynamic. All these things that I've explained, propulsion, navigation and aerodynamics, will all come together to get me into space.